Welcome to the architectural concept video and video series, of course. And today we are going to talk about application, application architecture, okay? Which is really very important for an effective solution architect because only if you know the architecture of an application, you can design an effective system for it. For example, if you need to design the scaling for an application, you should know the what kind of architecture that application belongs to. Okay, so to be an effective solution architect, you should know how the application is designed. It's not only for the developer but for the architect as well. So let's type here architectural concepts, and today we are going to talk about application architecture. Okay, this would really help you. I'm telling you, this would help you if you understand the difference between the application architectures, how it is happening, the things connecting to each other. It will help you immensely designing your infrastructure. Okay, so let's talk about uh, the part of an application which allows you to interact. For example, you are watching YouTube video, and how do you do that? You go to the browser, you type youtube.com, and you start looking for the video that you want to see. You search for the video and then you click on it and it starts presenting to you. Okay, so that part of an application which allows you to search and click and allows you to interact with the application is the part we call presentation. Okay, it's called presentation. Now, whenever we'll consider the same example so that it will help us to understand it completely. So I'm not saying YouTube is running on this kind of architecture. I'm just saying if you are browsing anything, any application, for example, Facebook or YouTube or Google, so the part where you can click, the part where you can browse is the presentation part. The part of application which lets you interact is the presentation part. Okay, now these videos are stored somewhere, right? You have your profile which is stored somewhere. When you log into the YouTube, you have all your history, you have all your information, even you have the information of videos if you left it in between, you know, those kind of information. Somewhere this is stored either locally or storing into a database. This part handles the data. If we talk about the same example, okay, so we have one more part of an application which is data. All right, it's very simple, right? Part which allows you to interact, and there is a part which keeps all the data, all the information. But in between these two parts, there is something which takes the decision, there is something which takes the action, okay, which is responsible for the logic of the application. All right, and that part is called logic part. Between these two parts, presentation and data, there is one more part which does things, takes the actions, and we call it logic part. Okay. Now let's go through it again just to be sure we understand it correctly. So architecturally, an application is consist of three parts: presentation tier, logic tier, and the data tier. Presentation tier, which interacts with the consumer of the application, logic tier, which delivers the application functionality, and the data tier, which controls interaction with a database of some kind. If now if these three tiers are implemented in the same code base and not separated, we refer to it as a monolithic application. Okay, so if I need to show you here, how would I show you? Okay, like this. All right, these three tiers are running on a same machine, you can say, or the same code base. All these three are implemented on the same code base. Okay, now in such situations it is very hard to scale the application, and generally if we need to do it, we'll do it vertically. Always remember. Okay, you can, because we know if load increases we need to increase the power of a machine, RAM, memory, CPU, disk, and all. So how can we do that? We can only do that by scaling it vertically. All right. So it's vertical scaling for monolithic application where all the tiers are in the same code base. And we call it monolithic. Okay. And this is called monolithic application. It's monolithic. All right. Hope this part is clear. Now, applications can be designed differently. Okay, if these three tiers, presentation, logic, and data, these three tiers are, let me bring here, we understand what these tiers are. Okay, so let me quickly bring these tiers here so that we can. Now, if these three tiers, presentation, logic, and data, are implemented as an isolated components, architecturally talking, these can be provisioned into on a different VMs, and they're connected to each other. Okay, for example, if you're connecting your logic with the data, you gotta change the connection string. Okay, so architecturally these can be provisioned on a separate machines or pools of machine, as each tier has differing demands on CPU, memory, or disk IO. It allows each tier performance to be managed independently. Okay, so it is like presentation, logic, and data. These are running on different VM. All right, but the point is, you see, I'll tell you. Let me create this first. Okay, this is done. So as I said, all these three tiers are running on a different VMs, and these are our VMs. This is, let's suppose, web server or web VM. These are our app VM. This is again app VM2, and this is our app VM3. Okay, and these are our DB, and this is also DB. So what is happening? All these layers, all these layers are on a isolated machines running, and they can be scaled independently. Okay, if you know what I mean, because web server has its own demands of CPU or memory. Same goes for logic. That's the reason I put three VMs here, a single VM there, because on web you don't have much, but on logic everything is defined here. We have database, which requires high IO to be in high availability. You put it 2 dBs here in sync. It depends, maybe always on, it depends. So this kind of architecture is uh, isolated in such a way that we can scale it horizontally. Okay, we can scale it horizontally, and we already talked about horizontal and vertical scaling. What is the difference, which is good and which is bad? And we all know, if your application can scale horizontally, it is something which is very helpful to make your application highly available, and it is something which make your application save money, because your all the layers are independent to each other, and they can be taken care independently. Okay, so let me write it down. That's how we can scale it, and let me write it down. It would be easy for all of us to make sense of vertical scaling when we will compare it later. Okay, now there is one more thing in the market nowadays, and which is called microservices. Okay, and microservices, where entire application is decomposed into small tiny micro applications which are packaged and deployed independently. Okay, so if I need to show you here on my sheet so that it will make more sense to you, I need to let me show you. All right, let's suppose this is your monolithic application, or monolithic app UI. This is the user interface for your monolithic app, and we have different services on our applications, right? Okay, let me show you what all kind of different services. Okay, now we have customer service, we have product service, we have cart, we have billing. Okay, we have all these components for our monolithic app. Okay, now if we need to see this application microservices, how would it look like? Because as I said, in microservices, where entire application is decomposed into small and tiny micro applications which are packaged and deployed independently. So if a user is sitting here, okay, suppose if a user, sorry, here is the user or a customer. Okay, Customer sitting here, how he is browsing, he'll go to the monolithic UI and find all the information right here. Okay, that's how it is happening. And these are connected to each other in a single application. But in case of microservices, these things, I'm sorry, sometimes I got excited and I do mistakes. All right, these components are independent of each other and packaged separately. Now, if a user is browsing, he is browsing, sorry, again, this is microservice UI. And if a user is browsing, he is browsing from here, right? And all these components are independent of each other. What that means? That means in case, suppose, in case if this doesn't work, somehow your customer service component is not working. What does it mean? It doesn't mean your application is down. It simply means this component is down and your application is up and running. And you can work on this component while your application is up and running separately. Okay, but this is not possible in the monolithic application. So I hope this would make sense to you and it would help you understand the application architecture. Well, thank you for watching. Let's meet in another video. Bye bye.